see a question, a shape, an obsession. It becomes a blueprint. I imagine what's next. Then come the systems, the countless steps. The momentum unravels. But I didn't choose this path to serve the process. The process was meant to set me free. To be fearless. To strive. To redefine what's possible. Unleash engineering brilliance. Trace.Space.
And we're live. Welcome everyone to the first ever Trace.Space webinar. My name is Amanda Bagley. I am the founding account executive here at Trace.Space. And my primary purpose is to help modern systems engineers by providing them the tooling they need to move at the pace of today's innovation. And I'm joined here with my sidekick, Matthew McLean. But before I throw the microphone over to him, let's do a little bit of housekeeping. Yes, this session is being recorded. We'll get a link to the recording as well as a copy of the slides after we finish to your inbox. Feel free to engage in the chat, drop some questions in the Q&A tab. We're also going to launch some polls. We want to make sure that this is an interactive experience for everyone here. So why don't we start with dropping in the chat where you are tuning in from. I'm in San Francisco, California.
I'm in Atlanta, Georgia.
All right. I see some of our team is joining from Riga, Latvia. Thank you so much for staying up. Amsterdam. All right. Very cool. Well, why don't we kick things off? Matt, will you get us started?
Absolutely. Thanks, Amanda. And hey, everyone. I'm Matt McLean, forward deployed systems engineer here at Trace.Space. If you don't know me, I spent some time at Anduril before this working on autonomous systems, where the cost of a bad requirement wasn't just schedule slip, it's a mission failure. That experience shaped how I think about all of this. And today I'm going to walk you through something most engineers are living with every day, even if they don't have a name for it yet, the compounding cost of bad requirements. And so we're going to cover the problem, where requirements break down, what it actually costs, and what the team that gets it right are doing differently. It's about 30 minutes, so let's get into it. So let me ask you something right off the bat. How many of you have been in a situation where you're 2 weeks from a CDR and someone asks you, wait, where do the requirements actually live? And the answer is somewhere in Jira or the Confluence page from 18 months ago or in someone's inbox or in their brain. That's a slide on your left here. IBM doors, Excel, Jira, SharePoint, Word, Jama, emails, brain cells. I've seen teams using 6 or 7 different tools and none of them talk to each other. And the most common engineering process I've seen in the field isn't building systems. It's fixing traceability right before a review. I've seen, instead of building what you should be doing, building the system. That's not rare. That's normal. And that's exactly the problem we're going to unpack today. But before I get into what's going wrong, I want to give you the why now context, because this problem isn't new, but the scale of it is. In 95, typical complex systems had 5,000 requirements. Today, we're talking 500,000 or more. And that's not a linear increase, it's 100 times more. And the real shift isn't just the number of requirements, it's the interdependence. Requirements don't exist in isolation anymore. Every single one is connected to dozens of others. And when you change one, the ripple goes further than you think. Our tools don't scale with us, and that mismatch is where the costs start building. And this slide captures something that I think about a lot. In modern systems, automotive, aerospace, defense, robotics, industrial, software drives hardware. Hardware affects safety. Safety ties into compliance, and every requirement in the system is connected. There's no such thing as an isolated requirement anymore. Every mechanical spec has electrical implications. Every software behavior has a safety case attached. When I was working in autonomous systems, we spent enormous amounts of time just trying to understand the dependency graph. Which requirements touched which subsystems? That shouldn't be manual work, but for most teams, it still is. And complexity didn't scale, it exploded. And the tools we're still mostly using, spreadsheets, word processors, basic issue trackers, legacy platforms with no significant updates in UX or functionality in years, were designed for a world that's 20 years behind us. That gap between how complex our systems are and how primitive our requirements management is, that's where the cost lives. And here's the thing. Most teams aren't carrying a single big problem. They're carrying requirements debt, and they don't even know it. Think of it like tech debt. It builds slowly. Year one, you've got a few undocumented assumptions. Year two, a handful of specs nobody's touched since PDR. Year three, a traceability matrix that's theoretically correct, but nobody actually trusts. And then one day, you just don't trust your system anymore. You don't trust that what's in your documents actually reflects what you're building. That's requirements debt. And unlike technical debt, you often don't feel it until you're standing in front of a certification body or a customer sneaks up on you. You can't even answer a simple question about your own system. So let's talk about 5 symptoms I see most often. And I want you to count how many of these sound familiar. Missing links, duplicates, ambiguity, outdated specs, unknown ownership. So let's start with missing links. These are requirements that have no test or verification method attached. This in the system, they're approved, and maybe we're even executing to them, but there's literally no way to know if they're satisfied. They're not connected to anything. Further, we've got duplicates, the same requirement, written slightly different across several documents. Which one is authoritative? Which one is out of date? Who knows? And next, and this is my favorite, is ambiguity. The system shall support user input. What does that mean? Who defined what user input is? What tests prove that we've got user input and we support it? And how do we know we passed? Nobody, except the systems engineer crying in the shower, thought to ask until 6 months into development. And now we're stuck. And then we come to outdated specifications. You know, the ones that have been sitting untouched since PDR. The system has changed 3 times since then, and no one knows what impact those changes have had on the product's ability to meet stakeholder needs, on the requirements of tests. We just don't know. And finally, unknown ownership. You ask who's responsible for the requirement, and you get 5 different answers, or worse, you don't get an answer at all. Every one of these is a landmine, and most teams are sitting on all 5 at once. And when I came into a program as a systems engineer, typically the first thing I do is look for these patterns. 9 times out of 10, all 5 are present. It's not a question of if. It was a question of which ones were going to surface first. Nowadays, systems engineers spend the bulk of their time on documentation cleanup, like traceability fixes, link updates, doc revisions, versus actually making stuff, actually doing the engineering work. Let that sink in too. Dozens, if not hundreds of hours spent on a program are going to cleanup, not on creation. And I've sat with teams where senior engineers, the people who should be solving the hardest technical problems, are spending their afternoons updating a requirements matrix because a review is coming up. That's not what they were hired to do. That's not where the value is. And it's not sustainable. And a quote on the slide, I love it. There's a whole subreddit devoted to systems engineering, and a large chunk is just concerned about wrangling documents. And I've heard some version of that quote on almost every program I've touched. It's ubiquitous. And that's the problem. Okay, so let's walk through something concrete. I want to show you what happens when you make one simple change. A sensor tolerance gets updated. And that's it. From plus or minus 0.5% to plus or minus 3% across the operating temperature range. A single requirement sounds totally manageable. But let's watch what happens next. Now, one change, a single tolerance update, touches the test cases attached to that sensor, the subsystem requirements upstream, the interfaces which connect the sensor to the rest of the system, the safety requirements, because the sensor provides safety critical data and firmware and the firmware spec itself for the sensor. To say nothing of the third and fourth order impacts of the change on the system requirements and those tests. In most teams, these connections are implied. Sometimes they're formalized, but they're rarely complete. Someone has to know the connection exists and then run each one down by hand. The person who made the original change, they might not even know that those dependencies exist. And the people responsible for the downstream artifacts, they might not hear about it for days or weeks. And this is how quality escapes happen. Not through negligence, through invisible, unmanaged, and incomplete connections. One change, 20 or more downstream impacts, and most tools won't even show you. So here's my favorite slide, or one of my favorite slides in the deck. Got a lot of favorites because it captures something that's so easy to fall for. And we've all seen this slide, okay? We've all lived this slide. We made this slide. You look at the requirements table, ID, text, verification method, status, it's clean, it's structured, it looks completely under control. But this view is lying to you. Here's what it doesn't show you. 001 and 004 are connected. 003, the IEC 61508 compliance requirement, touches every other requirement on that list. And 006 firmware timing has implications for 002 interface bandwidth. The rows give you the illusion of structure, the illusion of control, the illusion of knowledge. They don't give you the system. This is what those same requirements actually look like when you model the relationships not as rows, but as what they are, a network. The system already exists as a network anyway. Your spreadsheet just doesn't show it. And when you're making decisions in a row-based view about a network-based reality, you're going to miss things. And this is the core insight behind model-based systems engineering. And it's why the best teams are moving away from document-centric approaches. So let's do a quick little poll. Quick question for everyone in the room. And be honest with yourself here. How often do traceability issues surface right before a major review? Is it rarely? Is it sometimes? Is it often? Or, and I'm betting this is most of you, every single time without fail. It won't happen for me, but take a second. Let us know what you think. So if you answered often or every single time, this slide is for you. This is the CDR sprint, 2 days before a critical design review, and suddenly the team is scrambling. The trace matrix needs updating before CDR. There is a broken link. 004 to test 12 doesn't exist anymore for some reason. 12 requirements still have TBD on their verification method, and nobody can figure out if spec version 3 or version 4 is what should be referenced. The ICD got updated and nobody told the systems team for that one before. And this is not a failure of individual engineers. See, that's the thing. It's not on the individual engineer. Every person on that team is competent. They're capable. This is a process failure. It's the inevitable result of trying to manage a network with rows in a spreadsheet. The review prep work should just be a check. Instead, it becomes a fire drill. And what you present in that review, you don't even fully trust it. You hope it's right. And that's a very different thing. So let me show you the mechanics of how this goes wrong in real time. So we got one requirement, 004, system requirement 004. Sensor tolerance updated from plus or minus 0.5 to plus or minus 0.3% across the operating temperature range. So a change in the system, sensible change, it was approved by the right person, but what happens next? As we see here, two items are directly affected by the change, but several paths converge and diverge as we move toward the testing environment. When the test fails, how do we know what caused it? None of them were automatically updated. The engineer who made that change to system requirement 004 probably didn't know those implied connections even existed. They're in 4 different documents maintained by 3 teams. Somewhere downstream during integration or testing, or worse, in the field on a flight test, something fails. And the failure mode traces back to that one tolerance update that nobody propagated downstream. And that isn't hypothetical. This is a mechanism behind most quality escapes in complex programs. So let's talk about the actual cost here. US businesses lose an estimated $30 billion per year requirements errors alone. That's not rework. That's specifically requirements. Fixing a requirements error in integration is 78 times more expensive than fixing it at the requirement stage. And by the time you're in the field, you're looking at up to 200 times the cost. And then flip it around, right? Teams with clear requirements up front are 97% more likely to succeed. Not marginally more likely. They're almost certain to succeed relative to the teams without clear requirements. This is the business case for investing in requirements quality. It's not overhead, it's insurance, and it pays out at every stage of the program. And if you want to see what that cost looks like at scale, this is Boeing 737 MAX, a story I know we're all familiar with. 2015, Boeing engineers flag a single sensor vulnerability in the MCAS system in writing with documentation, but no requirement change was made. MCAS was certified and entered service in 2017, but the system still read from a single AOA sensor with no redundancy in place. In 2018, it crashes a plane. 5 months later, it crashes another one. What followed was a global fleet grounding for 18 months, the longest grounding of any U.S. designed aircraft in history, $20 billion in total costs to Boeing, $40 billion in market cap wiped out, a $2.5 billion legal settlement, and worst of all, 346 people killed. The root cause was not a bad requirement, it was a missing one with inadequate risk mitigation. A single sentence that nobody wrote, and the impact wasn't traced until it was far too late. And here's the part that gets me every time I look at this case. The requirement that existed using AOA sensor data to correct pitch was reasonable on paper. It wasn't wrong. It was never specified what happens when the sensor fails. What happens if the pilot hadn't received the risk mitigation training? What happens if they forgot the training in an emergency? There was no redundancy requirement. There was no check on that sensor quality. A faulty reading could command a nosedive, and there was nothing the system could do to stop it. In a connected model, the gap is made visible. It shows up as a missing node or a hole in the matrix. You can't miss it. In a document, in a row, you can miss it, and they did. Requirements aren't documents, okay? Requirements are systems. That's the fundamental shift. And once you see it, you can't unsee it. So What do high-performing teams actually do differently? They do 5 things differently. They store requirements as connected graphs, not in a document. Changes propagate automatically. Traceability isn't assembled before a review. It's managed continuously. It's maintained continuously. Completeness and correctness are a feature, not what you check when it's convenient or mandated. And AI isn't just a writing assistant. It monitors the model, suggests traces, and flags gaps before they can compound. The shift from legacy to modern is fundamentally a shift from passive to active requirements management. Documents are passive. Models are alive. So what does good look like? Let's get specific. Model-based requirements, every requirement, component, and test is a node in a graph. When something changes, everything downstream knows immediately. Not after a meeting, not after someone like manually updates 5 documents, right now. Validation shifts left. Requirements are reviewed for completeness, testability, and conflicts before work even starts. Not during integration, not during flight tests, not when you're validating with a customer. The goal is to catch issues when the right change can have the greatest effect on outcomes. And automated traceability. The links between a requirement and its design artifacts, its implementation, and tests are always maintained. No one manually updates the matrix. They don't have to. It happens automatically. And real-time change impact, before you approve a change, you can see exactly what that change will touch. Not a list of documents, the actual dependency graph, the ripple before the wave. And this fundamentally is why I joined Trace.Space. I've tried to make this tool, I've tried to make this work with legacy tools. This is the fundamental principle for modern systems engineering. I believe we need an AI native requirements and traceability platform built for us in the modern era for software-defined hardware, for automotive, aerospace, defense, robotics. Like with our graph here, you have your system model. Traceability is live, it's not assembled. Change impact analysis is automated. AI flags what's broken, helps you create requirements that aren't starting from scratch, and monitors quality consistently and all the time. For teams that are serious about requirements management, that's what purpose-built looks like. So I know we got a little heavy there, but I know, and I also know that you probably didn't think you were going to get out of the session without a little bit of a pitch. And, here's where it comes. Like, if you're feeling friction in the requirements process, whether it's pre-review chaos or, fire drills, invisible change impacts, gaps, or just an uneasy feeling that like you can't trust your data, I'd love to talk. Even if it's just to vent. I was a systems engineer. I've been in those shoes, and it's never a good feeling. But that being said, I'd be happy to hear from you if you do reach out. But thank you so much for spending some time with me. I know you're all busy. I know we've all got a lot going on, but I hope this has given you both the language and the leverage to start addressing these ideas. So with that, thanks again. I'm going to hand it back over to Amanda.
Thank you so much, Matthew. I learned so much in that session. And, your passion for systems engineering really shines through. So I hope everyone enjoyed that. We're going to switch gears. So today, Trace.Space just announced our new space agent. And when we were preparing for this, the team was deciding who should actually show space agent. Matt could do it. He's a systems engineer. Giannis could do it. He is our co-founder. And then we were like, what about Amanda? Now, I'm not a systems engineer. I don't live in requirements every day. I do speak to a lot of systems engineers. And the real question I had was, how far could we actually go with our new space agent? So I'm gonna share my screen and show you something that I've been building with Space Agent's assistance. Now, please drop any questions in the chat or in the Q&A. I'd love to kind of have the chat kind of help direct me in what I should be building today, but let's get into it. So, all right, cool. Okay, so something that I've been working on is I'm building a Batmobile. We thought this would be kind of fun, something that you can get really imaginative. So we have our customer, let's say that's Bruce Wayne. We've got the scope of the Batmobile. And what we're looking at here is our document view, which is something that could be kind of, obviously very familiar with where teams are working first. Like first, we're just in a doc. We're going to come up with the scope of the Batmobile system. Some just high level things, right? It's got to be able to fight crime in Gotham City. It's got to be fast, right? It's got to be able to chase the bad guys. It's got to be able to get away from the bad guys. And then, of course, it's got to have defensive protection systems. So we've got the name here, and then we have the description, and then going into our stakeholder needs. So this is effectively what, let's say, the customer has said that they need it to do. So we've got the name, we've got the text, and then we have the rationale behind it. So the Batmobile shall accelerate from 0 to 60 miles per hour in less than 3 seconds. So it's got to go fast. And the reason why is because it's critical. So again, going back to everything that I'm learning about systems engineering and how requirements are organized, created, and maintained. So this is our document view. But if I actually jump into our graph view, this is where you can really get an idea of where things exist, where things are missing. So for example, last week I was actually building out a drone launcher for the top of the Batmobile because Bruce Wayne said he wants to be able to launch drones from the top of the Batmobile. And I'm going to keep looking over at the chat here. And then if we jump over here into our requirements, that's going to bring in even more visibility again into what's missing. And the cool thing about Trace.Space, it's going to make some suggestions. Like they notice that there's a missing subsystem requirement trace, and we can add it, right? It's going to pop out here, and it's going to make some suggested items here that we can actually add as a trace. So I'm just going to do a random one here. And then just like that, we've got it showing up here within the graph. So that's our graph view, really just giving you a high level of where these traces are missing, maybe where we need a verification item. So we need to verify that this drone launcher launch pad is going to be able to work with everything that we put into the overall system. And going back to what Matthew said, is that requirements it's not a document, it's a system, it's a network. And this is where with Trace.Space, we can see that. So I always love us kind of like showing this off at the top of our demonstrations. But something that Matt really pushed for was for us to have like a traceability matrix view. So this is just another view where we can understand where all of our traces are. And we can do really quick traces here. So if I see threat detection needs to be traced to like ballistic protection levels, I can go over here, I can right click. And then something that's really cool, going back to me as somebody who doesn't have a systems engineering background, I can understand what I'm doing. So ballistic protection level is upstream of operational range, or is it downstream? Or maybe with the traces, we actually need to look at the parent and the child here. So here, none of these requirements have parents and none of them are childs. Again, me not really understanding what any of that means, but hopefully this kind of illustrates exactly where teams have the flexibility of where they can work out of. So of course we have the matrix view. It's going to ask me if I want to save it. That's fine. We have the matrix view, we have the graph view, and we have the documents view. So I'm going to ask the chat, what is a good stakeholder requirement that we should have for the Batmobile? So we're talking to Bruce and we're like, hey, is there anything that's missing here? Is there anything else that you want to have with your Batmobile? So if anyone wants to just pop in the chat what we should do there. Anyone has any examples or anything, and just hit me with. Of course, Space Agent is going to help me out. I got some questions about connection to system models. We'll definitely jump into that. And if I don't have the answer for that, follow up with it. You know what? I'll just come up with my own kind of example. Let's say, for example, and these are all really good questions. We'll get into space agent and talking about hallucinations there. But first, I think what I want to do is I want to make sure that the Batmobile can go underwater. Oh, Giannis wants be able to shoot lasers at small drones. Let's start with an aquatic Batmobile, if you don't mind. So if I'm going to go over here, this is Space Agent. Now, very important. Space Agent is not making decisions for you. It's not doing things for you. It is assisting you. So it's gonna, one, detect if there's missing traces. It can give you even its thoughts on the overall system itself. So let's say, for example, we want the Batmobile to go underwater. Be able to function underwater. Now, keep in mind, we can connect into any of the major LLMs that exist today. I'm using Claude Sonnet because I've been a big fan of Claude recently. But something that's also awesome about Trace.Space is we can connect into your company's models. So for example, you've been training a model on all of the systems you've been building, your internal nomenclature and the way that you have things described and the way things work. We can connect Trace.Space directly there. So it's also taking in consideration everything that you've trained in context. So I'm going to use Claude Sonnet and I'm going to say, we want the Batmobile to be able to function underwater. So Space Agent is doing its thing here. It's kind of reasoning with what I just asked for. It's going to look for any existing items that might be related to aquatic Batmobile functioning. And it's going to generate my response. Now, what I love is you can go in here in real time and being able to see like exactly what's it thinking about? What is it processing here? And that goes to Kemi's concern about hallucinations. Again, we are working with the top LLMs. Oops, I didn't complete. Let's try that again. I love that when we're in a live demo. All right, so what it's doing is it's going to create stakeholder needs for underwater operation. Love that on a live demo. So let's do the good old refresh. Okay. Create a stakeholder need for underwater operation. It's going to know what I'm talking about, even if I spell it wrong. Okay. Why don't we ask it to suggest? All right. Giannis is saying, let's try OpenAI. That's me. Should we do chat GPT 5.1? So why don't we tell it to suggest a stakeholder need? I'll go into a new chat here. Okay. All right, cool. Well, OpenAI wins today. Well done. It's giving me something. Now, one thing that a lot of teams love about Trace.Space is we can take into consideration when we're actually setting things up. If your team only wants to create requirements that are adhering to INCOSE standards or EARs, and like I said before, if there's any specific type of conditions that you want Space Agent to consider in creating requirements, it'll automatically do that. So let's keep this purely a stakeholder need. Yes, let's start out with high level. And that's right, Kemi. You can configure it to format for requirements to adhere to. All right, and just like that, Space Agent has suggested, very important to say suggested, a stakeholder need for underwater operation capability. So we've got the text for it, we've got the rationale behind it, and I'm looking at this and I'm like, okay, this is pretty good. Look at the attributes. What would be the validation method? Yes, we'd want to validate it by demonstrating whether or not it can go underwater in a very controlled, maybe we have like a pool available for us to do it. And just like that, I have created a stakeholder need for underwater operations. I can view it here within the graph view. I can also go back and look at it in the document view. Cool. Now, what we're looking at here in the details is, of course, we can see the type of item this is. We can run quality checks. So this, again, is Space Agent already getting ahead of any kind of reviews and saying, hey, this checks out based on everything you're telling me and how we want to build out these requirements and what our entire system has going on today. It looks good. Now, what it's flagged is we have some missing traces. There isn't anything related. We haven't connected it with anything in the system. So I'm going to ask Space Agent to help me with that. Here's some suggested traces. But the main thing is now we haven't created any like downstream requirements, subsystem requirements, component requirements for this stakeholder need. And also when we're talking about collaboration, I can say, hey, Matt, what do you think about this? You think about the Batmobile going underwater. So this is where we also have the collaborative functionality with Trace.Space. I'm not trying to chase him down on Slack, sending him an email, texting him or something like that. All of this is happening right here. And then when we talk about reviews, so I can actually send this to review. Now, typically teams will kind of get to a certain point of when they're building everything out and then send everything to review. But this is where I can add it to an existing review. And very importantly, we can see the versioning here. So if somebody came through and changed this, we can see that already right here. So again, it's not a bunch of disparate documentation that we're digging through, who did what. We can see all of this in real time within Trace.Space. It looks like things are getting really active in the chat, which I love, but I'm going to keep going here. And why don't we ask Space Agent now let's create well, first I'm going to say that looks great. Thank you so much. So we always want to be nice to Space Agent because Space Agent is just so good to us. Oh, and since it knows we're building a Batmobile, I love that. It's always adding this bat emoji. What about the linkage to architecture and interface requirements? I think we'll probably get to that if I keep going here. So we've got our stakeholder need here. It has to go underwater. Now, can you help me think about what will be a downstream requirement for this one? Really what I'm trying to show here is, again, I'm not a systems engineer. I know a lot goes into this. You've done a lot of education to get there, but we thought it would be funny to just be like, okay, can Amanda actually demonstrate this? So it's thinking about the things that would flow into it. And then also something that's really important is it's always referencing back to the items that we already have created. And this goes into that concern about hallucination. So Trace.Space is showing us their work. They're showing that like, all right, this is what we're talking about here. So here are some requirements that we should consider for underwater operation. Do we have the pressure resistance? Can we actually go fast underwater? I guess in that case, do we have a propeller? What happens if something goes wrong? And do we have any oxygen for Batman? Navigation, electrical system isolation, underwater communications. So why don't we'll start with number one. How about number one? Start with structural integrity. Awesome. And just like that, Space Agent has created a new requirement for me, and it determined that this needs to go into system requirements. And I think, I don't know, 30 meters, the way I think that Bruce was looking at this is my Batmobile needs to be able to go underwater in like a sewer, for example. But I also believe that Gotham City has like a river or something. So we don't need to be able to go super deep. But I think 30 meters is a good place to start. I think also we can probably accept this. So we see the text, the rationale, all of that checks out. Let's accept it. And boom, now it's right there in our tree where we want it to be able to go. I can pop over here, see all of the additional details, traces. Again, it's saying we don't have a stakeholder requirement that we want to trace that to. But I bet you I could do that if we wanted to go to underwater operation capability. Boom. So now at minimum it has that. Now we need a subsystem requirement and a verification. Very important there. So why don't we keep going with Space Agent, move on to underwater propulsion. Okay, let's do underwater propulsion. Boom. How hard is it configured for non-standard layouts, manufacturing specifications, instrumentation? That's a great question, Nicholas. So this is definitely going to be in setup, and Giannis, keep me honest if you want to pop there in the chat. But this goes into setup. Now, keep in mind, we can import any content. So we have very flexible API. We can connect to the existing platforms that you're managing requirements and bring those into Trace.Space. And then in addition to that, if there's any kind of content, for example, it's like, we have to, especially medical devices, we have to be able to adhere to different certifications that we're going to see when we're in front of, the people that get to say whether or not we can ship this medical device. All right, so here we are. We've got the propulsion. Now, it's saying that, I don't know, 9 miles per hour is a reasonable underwater speed. I feel like we should be able to go faster. So we might need to make this an actual speedboat underneath. At least more emoji. And you actually, you can actually at the people that you want to respond to within the chat. All right, how fast are we thinking? I want to keep an eye on time because we could do this forever today, and I'm sure people have other things to do. Let's do 20 knots. Bruce is like, I need to be able to go super fast underwater in my Batmobile. It's like, okay. Cool. All right. So it created the requirement for me. That's seriously capable underwater. I love the personality of my Space Agent. You can accept this. I suggest traces from both this and the structural integrity requirement back. So going back to Space Agent is helping me. Space Agent is making suggestions here. Space Agent has told me, hey, this is that we should probably trace it back to, which makes total sense. So I'm going to accept this. I see it here in the document view. We'll go over here to details. And then based on that suggestion, we can have it go to that specific requirement. All right, so I'm going to switch gears and we'll actually kind of get into like the semantic functionality of our Space Agent. So let's say we're kind of halfway through some kind of project. And leadership says, hey, where are we with this? Now with Trace.Space, we can bring up dashboards, we can show you kind of where we are. But what if we just want to give them a Slack message from Space Agent saying, I'm going to ask Space Agent, how are we progressing with the Batmobile overall? What do you think? So it is looking at everything that we've built in context, and I guess doing its own kind of discernment of how it's doing. I'm just going to take a look here at the chat. You have things like yes. Cool. Love to see people engaging in the chat while we're doing the live demonstration. All right. So again, showing us first what it's doing. And now it's producing something like this where I can easily copy and paste it. And keep in mind, Space Agent's working really hard here. All right, so we see 87 requirements across multiple levels. That's a solid foundation. And here's a summary of what's in place. We've got performance, we've got protection, stealth, autonomy, aerial assets, underwater operations. All right, traceability gaps. This is where we can actually see potentially where we have things missing and where we can actually, it could be too late before, this is like, we want to get this all sorted before review. And as Matt just went on in his kind of sermon talking about, like, oftentimes we don't even know where we can find these gaps. We don't even know where we should be looking at. And then duplicates, right? There's different requirements that have almost the same name. Even if it's not the same wording, it's almost like the same kind of like concept. And then we still have some more requirements to do with our underwater stakeholder requirement. So I need to send a Slack to my boss just with a summary. It should be short and casual. Bang. Well, all right. Got 87 requirements across the board. Oh, you know what else? I want to know who's doing the most work on this project. So who is going into Trace.Space and doing the most work? Of course, we can see that. We can see, like, the logs of everyone who's logging in, but maybe we just want to see what Space Agent in terms of, how we are splitting up all the work here. Okay, so obviously it's Matt and I here. Oh, okay. Well, Matt is clearly doing the heavy lifting, and I'll give it to Matt. Matt's the person who set up this instant for me. But I have been doing some more focused, high quality work, right? So if you think about it, kind of like in the setup, Matt kind of created the framework, and now I've just kind of been adding things on. So, but I love how, it's kind of saying it in, as a human, like Matt's doing the heavy lifting, but you can see specifically what I've been working on. So we were talking about emergency ejection, talking about unmanned aerial asset deployment. That was last week when I decided, well, Bruce decided he wanted a drone launcher. And just right now when we were working on the underwater operations. Well, so I'm going to try and push Space Agent a little bit now. Maybe not push it. This is actually like the primary use case here. Tell me where there are missing traces across the whole system. And I spelled across wrong, but it knows what I'm saying. Bang. So of course we can see this in the graph view. Of course we can see this in the traceability matrix and everything here. What about just at a glance? I just woke up and I'm like, oh my God, we've got a review next week, or we got to stand up with my boss. I got to know where all of our missing traces are. And actually, I'll jump into that semantic search that was just asked about in the chat here in a second once we get done doing this. Got about 11 minutes left. And we will be having a follow-up session that's entirely dedicated to Space Agent, probably in a couple weeks. And then we'll have some more ongoing webinars just talking about what's going on in the world of systems engineering today. Now, of course, I have a lot of items and requirements here, so it is going to be sifting through a lot and running that get traces tool. Architecture overview. All right, cool. So it's analyzing what it's found in terms of trace rules. It's going through everything here. And I just love how, it's kind of talking to itself in front of me. So I can see in real time how it's doing what it's doing. Oh, you know what it is? I switched back to Claude. All right, here we go. So this is where it's told me kind of like high level where all the missing traces within stakeholder requirements. It's considering all the rules. One thing I wanted to show, just looking at time, and I think part of it is I'd switched to Claude back from OpenAI, but something that Giannis mentioned in the chat, and this really goes into like semantic. So if I just pop in danger here when I'm trying to search for a requirement, now we do have danger where it appears in some specific requirements, but also it's kind of looking at, okay, threat is kind of similar to danger. So that's how when we're actually searching for things, we don't necessarily need to have that exact word. It can be a concept, it can be a phrase. And then what it's going to do is then surface requirements that it believes are most relevant to that word. Let's say flying. And that's pulling up the scope there. So let me see if he ever finished what it was doing here. All right, it didn't complete its work. Maybe we can try again. I'm looking at the time. Let me switch back to GPT 5.1. Just create a few requirement, or tell me a couple missing traces. Let's see if OpenAI is working better. Okay, so here are a couple high-level missing traces. Okay, so we have the underwater stakeholder and the propulsion requirement, but there is no trace there. Aerial stakeholder need with no downstream requirements. Well, now we know that was a lot, and of course there is a lot more to see. We are going to be following up with the recording as well as the slide deck, but I figure now would probably be a good time to wrap up. So I'm going to stop sharing my screen. And yeah, so thank you everyone for joining. We hope you got something out of it. Maybe if you didn't today, you'll join us for upcoming webinars. We're really excited about what we're building here at Trace.Space, but more importantly, bringing more awareness to the challenges that our systems engineers that are building the most innovative products that the world has ever seen, and making it so their lives are easier. Thank you all. We hope you guys have a great rest of your Thursday, and we'll see you next time. Bye-bye.